All right, so we're going to be looking at related rates again, this time by solving this problem. We have an ant walking along a curve, y equals 1/3 x cubed plus 1/2 x squared minus 2x, with x changing at a constant rate of 3 units per second. We want to know how fast is y changing when x is negative 3. So we have our curve, and this is the curve y equals 1/3 x cubed plus 1/2 x squared minus 2x. We want to know when x is negative 3, how fast is y changing, given that x is changing at a rate of 3. So dx dt is 3. We want to know what is dy dt. So in order to do that, the first thing we need to do is we need to find our derivative. So we already know that y is 1/3 x cubed plus 1/2 x squared minus 2x. So we're going to take the derivative with respect to t. And so we get dy dt equals 1/3 equals x squared plus x minus 2 dx dt. And so this formula allows us to calculate dy dt for any given value of x and dx dt. Since we know dx dt is 3, we just leave that as 3. We just need to plug in our negative 3. We wanted to know what is dy dt when x is negative 3. And so we calculate that and we'll get our answer. So that gives us negative 3. But this formula allows us to do the same thing at any x value. We could find the value when x is 0. What is dy dt? Simply by plugging 0 into our graph, or 0 into our equation, and leaving x as 3. And we can do that at any point on our curve. We can find dy dt simply by plugging it into the equation. Now, of course, this is really not a complicated equation, so it's fairly easy to do. We will look at some next time that are harder equations to plug in the values for. So again, we got dy dt equal to x squared plus x minus 2 dx dt, and then we simply plugged in our x value and our y value to find out the answer we need for the problem.